Lesson 1-6 is about the commutative and associative properties. The commutative property states that the order in which you add or multiply the numbers does not change their sum or product. So an example of that would be if you had 8 plus 6, that's the same thing as 6 plus 8. It doesn't change the value of it. 3 times 2 is the same thing as 2 times 3. The associative property says that the way you group 3 or more values when adding or multiplying does not change their sum or product. So, in other words, if you have 3 plus 4 plus 7, that's the same thing as 3 plus 4 plus 7. Okay, so we can group them any way we want, and it won't change the sum or the product. And if you're wondering why we would do this, why this would be helpful or useful, let's look at an example, another example, and let's take 8 times 2 times 3 times 5. It would be easier in this case for us to group the 8 and the 3 together and the 2 and the 5 together. And that's because the 2 and the 5 together would make 10. And it's always easy to multiply any number by 10. So 8 times 3 is 24. 24 times 10 would be 240. Okay, and you could see where that would be a lot better than if we had kept the problem as it originally was. If we had kept this original order, we would have had to have multiplied 16 times 15. And that is probably something that you couldn't do in your head, that you couldn't do mentally. But 24 times 10 is. But either way, it would be 240. So it gives us the same value, but in an easier way, in a way where we can figure it out without having to get a calculator or paper and pencil. Okay, so a key point here is that these properties only work for multiplication and addition. Associative and commutative properties do not exist for subtraction or division. And we can prove that simply by trying it. If we were to take 7 minus 3, we know that that's not equal to 3 minus 7. 7 minus 3 would be 4. 3 minus 7 would be negative 4. Those are not equal to one another. So let's look at another example. If we were to evaluate 8 plus 14 plus 22 plus 9, and we did it in the order given, it might be a little bit more complicated than if we would look for some compatible numbers. So look for some numbers that when we add them together, we're going to get a power of 10, some zeros on the end, like 8 and 22. If we added 8 and 22 first, we would get 30, and then we could add 14 and 9 and get 23, and then add 30 and 23 together to get 53. That's probably a lot simpler to do it in that order, to do 8 plus 22 plus 14 plus 9, than it would be to do the existing order. So if we looked at our original problem and did that, then we would have more complicated addition to do. We would have to do 8 plus 14 is 22, plus another 22, plus 9, and that is doable, but maybe not as easy as if we grouped 8 and 22 together first. And lastly, there'll be some work that you'll have to do where you're combining like terms. And that shouldn't be any big deal at all because we did that a lot last year. So if you have 2y plus 2x plus 8y, you look for terms that have the same variable to the same power, and you group those together. So we're using the associative property or commutative properties to change the order or change the grouping so that we can combine like terms. So this would be 2x plus 10y. And let's see, we'll do one more example. If we have 4a cubed plus 6a plus 3a squared plus 8a, and we combine like terms, once again we'd have to change the order. We would do 4a cubed plus 3a squared plus 6a plus 8a. And then, of course, these two are the like terms, so we would combine them, and this would be our final sum. So that's it for today.